Uh, so hello, welcome to Meet and Analyze Data. Today we'll do a lesson continuing on what we were building on the end of last quarter. Uh, so we ended last quarter, the last two lessons were on Snakemake. So what we are going to do today is put together the conda environment management that we were doing in the beginning of the quarter with the Snakemake pipelines, and to try to show it to you how this is useful. So the presentation is kind of the same as that we were going, and it's like one detail on the full lesson, which is, where is the, no, here. So it's the last thing on the lesson. But let's kind of start from the beginning with this. So I created a directory here that has the content of that lesson, the snake file, and so on. We can remove the environments for now. Okay, so also going a bit into the how do you organize your project. Something that I really like to do when I'm creating a new Snakemake pipeline is to put a README file documenting how I initialize the smallest possible conda environment to run all my analysis. So if we look at the README file, there is this command. I should have more information on the README file than that, but it's a beginning. And if I run this command, what's going to happen is that conda is going to create an environment using the description on this file in the environment.yaml. And if we look at that file, the only thing that's there is a dependency called Snakemake minimal. So Snakemake minimal, for when you install this through conda, what happens is that it installs just the kind of the Python parts of Snakemake, just the minimal things that you need to be able to run Snakemake, because Snakemake has a lot of features that could bring a lot of other packages and other dependencies, but we are trying to keep this one small. So when I execute this one, I'm going to do the usual collecting metadata and finding the packages, solving the environment. Yeah, so now I have an environment created that I can run conda activate snakemake conda, and I will have snakemake available to run. So if I try to run snakemake here, I don't have the command. If I do conda activate snakemake conda, and I try to run snakemake, oops, I'll do -- help. It will print the help message. So now I have snakemake available to run my workflow. If we look, I'll remove those two directories because those are created by the pipeline. So three basic things: starting a project, put a README file saying how you initialize your environment. The snake file is the description for our workflow, what's going to happen, and the environment.yaml has the basic dependencies that need to be just to install Snakemake and get started. So now if we look at the Snakemake file, so this is the same one that's in the end of this tutorial, is this one. The only thing that changed here is that I added an extra rule for downloading the data, because since this tutorial is from Angus, and downloading a lot of data when you have 60 people doing it at the same time is horrible for the network. So you don't want to do that all the time during a tutorial. But in this case, I want to have something that, given a list of samples from the SRA, I can run a command and download all this data. So it's more self-contained than what was happening with Angus. Because in Angus, there was one directory that had all the data already available for you, so you wouldn't need to download it. So the only difference between this this one and the Angus tutorial is this rule that's going to run fastqdump, which is a program that comes from a package called SRA tools. And I put a reference here going to the non-official documentation of the thing, because I think the first phrase here says it all. fastqdump has to be one of the worst documented programs available online. It's really hard to understand what's happening when you try to run fastqdump without having more details. But they are nice here, and they have like, this is the command that we usually run with some parameters already set to do the right thing. So that's pretty much what I copied and paste here. Just broke a bit the lines to be able to read better what's happening. So what this rule is doing is that it's generating an output file, so it doesn't take any input files. It's generating the output file from downloading stuff from the internet. There are other ways that you can do this on Snakemake. I think they are way more complicated than doing this. So what I usually do when I have a rule that has to download stuff is that it only has an output, and then it has the command on how to download the data and put on the right place. So the command for downloading the data is this long thing. The name of the SRA session that we are going to download is this wildcard sample thing, which matches this part of the file. And this comes from, eventually from this name. So this is the name that's going to be passed here to download the data from the SRA. And then we are redirecting everything to the output file, which is this one. So this is the rule for downloading the data. It depends on having SRA tools installed. So if I don't have conda environments for this pipeline, I will need to go and remember what I changed. If I don't have SRA tools installed on my computer, one approach that you can do is that you can change the environment file and put SRA tools here. Or you can do like conda install SRA tools. And this will download the SRA tools eventually and install everything. And you can start seeing that SRA tools is something that brings a lot of dependencies. That if I install the SRA tools here in this environment, in the base environment, it's going to bring all these dependencies and put on the thing that was supposed to be minimal and only have Snakemake. Since this is the first program that I'm installed, there is no big issues. But this pipeline, for the people that were in the previous tutorials, it's doing the important things that this pipeline is doing is not really downloading the data. It's running fastqc on the data and then collecting all the reports to generate a multi-QC report. So this pipeline is doing, if we look at the, so this, can make this a bit bigger. The pipeline that we are defining now, there is an extra step on top here that's downloading the data, but each one of these is a fastq report that's being generated, these ones. And then multi-QC is putting them all together so we can, it's a bit easier to compare samples to see what's happening with our sequencing data. So if I start installing SRA tools, fastqc, and multi-QC in the same environment, that's probably not going to be an issue. But as your pipeline starts growing and growing, you will have many steps that will be doing very different things. And you might start getting into situations where you need a SemTools version for one tool of in your pipeline and another SemTools version for another tool in your pipeline. And if you have everything on the same pot, that's going to go badly because you can install two versions of the same package on the same environment. So how do we fix this? Well, first thing, if I don't have anything installed in this and I try to run Snakemake, it's going to give me a lot of red error messages saying that I can find the command. So I don't know how to run fastqdump because fastqdump is not available here. So what we will start doing is that instead of installing everything on the same environment, we are going to define, in this case, one environment for each rule, one conda environment with the dependencies just for running that rule. So to do that, what we need to do is we add this new option on a rule, which is called conda, and you give a path to an environment file. So I'll call this environment.yaml. If I look at my tree here, again, I don't have that directory that I put there, so I'll create the directory. And now I need to create an environment file that has SRA tools as a dependency. Because I'm lazy, I'm copying the environment that I have here into the SRA tools.yaml. And then I'm going to change SRA tools.yaml. The name is not necessary for conda. So the thing that goes into an environment file is the channels that you're going to use. And because we are using bioconda to install software, this is the order that you need to put the channels to be able to install everything properly. And I'm going to remove, I actually need to remove from the other one also. Like, no SRA tools here. So my environment file is going to be fairly simple. It will only have SRA tools. If you have a rule that needs more software or is doing something more complicated, or you need like a specific Python version or R version for that rule, you can also specify here. So for example, you can put SRA tool. You could put here like Python equals 3.7. And that would work for installing Python just for that environment, but not for the others. But we only need SRA tools. So now if we try to run Snakemake, it's again complaining that the command was not found. So how come, like, we have the conda description on the snake file, we have the environment here, so why this didn't work? The thing is that Snakemake, when you're using this feature, you need to pass an additional parameter, which is --use--conda. And then if you give this parameter, what's going to happen is that Snakemake will check all the conda environments that you have defined, see which one it needs to execute this workflow, and then it's going to build the environments for you. So what it's doing now is that it's checking the conda environment in SRA tools.yaml. It found that it needs to install SRA tools, so it's creating an environment and then putting SRA tools in the environment. And as soon as this finished being created, then it can run the fastqdump command that we put on the rule and download out of it. So that's what's going on. It's running 1, 2, 3. Can count. It's running 6 jobs. Yeah, 6 files being downloaded. It's creating the new data directory. So if we look at the data directory, it's starting to download all the files. It's actually running 4 jobs at a time here because it found that my computer has 4 CPUs. We can watch live how data is getting bigger. Anyway, the rule will finish running eventually. But this only works for our first environment. So this one, the download rule, now has an environment that says, okay, this is the way that you install SRA tools, and you get the fastqdump command that I'm using here. Cool. High CPU usage, like in the meeting volume. But these other 2 rules here, they don't have the conda environment specified. So when we get to the point where we can calculate a fastqc command, it's going to complain that now fastqc is not available. So what we are going to do to fix that is that we do the same thing that we did before. Let's go to the environment and copy the SRA tools into fastqc.yaml. Oops, fastqc, not fastq. And we edit that. Instead of SRA tools, we are going to ask for fastqc. Good practice, use specific versions for the things you're reinstalling. In the previous one, I only put SRA tools, but SRA tools might get new updates and might break something in weird ways if you don't put the proper version. And it's also a good reminder when you come back in a year to this pipeline, what were the exact versions that you were using. So in this case, I don't remember what fastq versions are available. We can search for it. Okay, so we have 0.11.8. So let's go with this one. Okay, so now we have the environment file with the version, and we need to add that to the snake file, which is not here. Okay, so again, it's going to be the same thing as that one. I like to put this one after the input and output. No good reason, could be anywhere. But fastqc.yaml. And just because we are here, let's also do the one for multi-QC. So this one will be /multi-QC.yaml, which doesn't exist. So fastqc multi-QC.yaml. Let's edit multi-QC. I again don't know what versions of multi-QC are available. Oh, many versions. So 1.8 it is. Multi-QC. Cool. Okay, so this one finish. Yes, sorry. So they are like, if you look at the go to the environment files, I have three. Yeah, so the fastqc, multi-QC, like the channels is always the same. And I would really like, I'll show later a pipeline that uses this, and I would really like to have on Snakemake a way of saying like, use this as a template and only update these parts. But you need to copy like these channels here to make sure that it's set up properly. Yeah, so conda is going to, yeah. So the issue is that if you don't put this configuration and you didn't go to the bioconda, so like the instructions for installing bioconda, one of the first here is the setup channels. Yeah, if you run this on your computer, conda is always going to use this order to resolve. Since you can be sure that you always run this. If you don't, then you can specify on the environments and then you're safe to go. So that's why I always put there, because I tend to forget to run these three commands. But pretty much like, it's kind of wasteful to have like the same 3 lines all the time and only have one dependency here. But as you have more complicated things and you need more dependencies, this file gets longer. Yeah. So let's go through that Snakemake, that snake file. Yeah, so the good thing about Snakemake compared with Make is that this actually gets executed as Python code eventually. So you can import like pandas here and use to decide the rules, and you can keep building up on this to when you like. For example, in the lab we have software. There is one called Space Graphicats, for example. That's actually a Python program built on top of Snakemake. So you call as a Python program, but inside it's always Snakemake rules to keep the dependencies and update and install all the software. So Snakemake is quite powerful. I usually don't do these crazy things. I usually just use for like this. So yeah, so when you put the input here, so what's happening, the way that Snakemake resolves what needs to be executed, if we go back to this image, is that there is a target, which is target all. And if we look at the code, it's this part here. And we are saying the input for the target all is this file. So then Snakemake is going to look at this and say like, okay, how do I generate this file? So this file is being generated by the multi-QC rule. It's the output here. So then now Snakemake went one step up, and then it says, okay, what are the inputs for generating this output file? And then it's this thing. It's this expand start of a name sample.html sample equals samples. So what this one becomes is that it's saying for this variable here, the sample, replace with everything that's in that samples list on the top, which is this one. So if you look now at the execution graph that's being generated, so the input for multi-QC is that expand that has the sample equals this one and the other one and all these 6 data sets. And the benefit of doing like this is that if you want to put another sample here, you can go and just add a new one here. And then Snakemake will figure out, okay, I already calculated this 6. You added a new one. I will calculate only that one and then update the multi-QC rule, picking up everything. So yeah. And yeah, so if you keep going up, like then it finds, okay, you expanded this rule. So for generating each of these files, I need to run fastqc. And for generating each of these files, these 2 files, I need to go find this input. So this input will find the download. So Snakemake starts from the all target and keeps going up and finding everything that it needs to execute. Where was I? Okay, so we have the environment. Oops, this one is already done. Okay, so now if we try to run snakemake --use conda, it's going to pick up the other 2 environments that we created after the SRA tools one. So the multi-QC and the fastqc. It's going to go install everything properly. And then it's going to pick up from where it failed before. So on the previous step, what we managed to do was the thing that's not showing up here, but was downloading all the data. But these steps here, they fail because we didn't have the commands installed. So now that we have the conda environment properly set up, what's going to happen is that it's going to see, okay, I already did the download. I have all the data locally. I don't need to download again. So the download step is already done. It's not going to be executed again. But then it can pick up the fastqc parts and run it once it finishes installing everything. Any other questions while that is being executed? Nope. Okay, so now we are doing the fastqc steps, and then this is the output for each fastqc command. It's kind of everything mixed in the middle because it's actually executing 4 fastqcs at the same time on my computer, which probably looks horrible on my CPU. Yep. That's a lot of Java running on my computer right now. So this is the other benefit of Snakemake. Once you start exploring how to make this stuff run in parallel, you can actually put your cluster down because you can start submitting a lot of jobs and doing everything at the same time. Right, Taylor? Yet. So because if you go back to that image on how this is being executed, we can see that this rule here depends on all these others, but these other rules, they don't depend on each other. So if you make a shell script that's smart enough to figure out that stuff can run in parallel, you can make that. It will be horrible and very complicated to keep everything running in parallel and figure out resources and so on. Snakemake has this built in. So if you have only one CPU or computer to run, it's going to run one job. But you can give more resources to it. And as long as things don't depend on each other, it can execute a lot of stuff in parallel. So it's very useful for making analysis run faster and finish earlier. And in this case, again, it started running 4 of them, but there were 6 in total. My computer only has 4 CPUs, so it didn't try to run all 6 at the same time. It ran a batch of 4, and as they were finishing, it put the other 2 to run at the same time. Okay, so now there was another one left. Yes.
What was the command that you used to be able to see like the jobs running?
My computer. So this one is htop. Usually computers have this one, top, but it's very black and white. So I like htop because it's more colorful and can do other stuff like filtering. But, yeah. So. Yep. Yeah. Mm-hmm. Mm-hmm. Yeah, so this is an annoying thing about Snakemake when you're transitioning from a shell script or something, is that shell scripts execute in the order you put stuff. You can have functions in the middle and call in the bot, but it will go in order. But Snakemake is, you're kind of declaring how you're generating your data, and then Snakemake is going to figure out in what order stuff is going to run. So as convenience, because makefiles also have this, usually the thing that you put on top is this rule all, because it's the first that's going to be executed. And it's the last thing that's going to be in your whole pipeline. So this is actually the final result that I'm generating. Yeah. And then from this, Snakemake is going to figure out the order to run everything else. Yeah, it's just the sites. Yeah. Okay, so this actually finished running. So I now have a multi-QC output somewhere. Let's open this. Here's the multi-QC report for all that data. DC bias, so on. So now you can analyze your data and compare all the things at the same time and so on. So, yay. What else should I say on this? I think for managing conda environments, that's it's not much on top of doing on a regular Snakemake workflow, but it's very useful because now this is there's a lot of data mix here now in the middle, but the things that I need to ship for this project or put like in a repo for reproducing this analysis later is this environment file, the envs directory with the environments for each rule, and the snake file and the readme, like the fastqc raw and the data. These are outputs that are being generated by my pipeline. But the benefit now is that if I have a repo here running on my computer, now I can copy and put this repo on farm, for example, and run there, because they have conda available there. So I start with that readme command again, and now I have an environment. And then with this, I can run Snakemake and let Snakemake manage all the dependencies and so on. So it's a very nice way of having reproducible pipelines for your projects. So as another example, I'm going to show this. So this is for the software that I work in the lab. It's called Sour Mesh. And for a long time, we didn't do performance tracking very well, like checking how much memory and CPU the commands were taking over time. So what I created here, this is, it's kind of the same structure that we have on the example I was giving today. There is a names directory. There is a scripts, which is another thing. There is a make file just because I'm super lazy and I don't want to type all of this. So I just type make and it actually executes, not important. Has the snake file and the environment for the base environment for installing Snakemake. But what's happening on this pipeline is that I'm generating, each time I have a new version of Sour Mesh, I go and put a new version here. And then it plots all the data again with another time point for a bunch of commands. So what this snake file looks like is that I have something similar, that I have a list of versions on top that I use to define. It would be kind of like my samples list on the example I was giving before. But what I do is that for each, let's go to a role that's doing something here. This conda environment is using the version for Sour Mesh to decide what file is going to be added. So what happens here is that if I go back to the environments, I have one environment for each Sour Mesh rule. And then when I have a new version of Sour Mesh, I create a new file here. I bump this version of Sour Mesh, and now I can rerun all my pipeline and regenerate all the plots and all the data and all the benchmarking for it. But the thing here, and that's what I wanted to show, is that the rule for each task that you can do with Sour Mesh, so for example, the Sour Mesh compute, it's always the same command. But I actually have one environment that has Sour Mesh 2.0, one environment that has Sour Mesh 3.0, one environment that has Sour Mesh 2.3.1. But it's always the same rule, it's always the same command, but it executes with different versions of the environment. So especially for benchmarks, it's very good to have like the conda support, because you can install specific versions of the software and run the same command over many different versions, for example. And that's it. Any more questions? No? Good.
How would the pipeline look like on the farm whenever you do requests?
Maybe we can do a tutorial one of these days, because it's a bit more involved on how you declare stuff. But pretty much what you're going to do for farm is that you can specify some other things on your snake file here, like besides the conda environment, saying like, how many resources do you want? Like, I want 4 CPUs and I want 2 gigs of memory, or so on.
So operate on.
For, in this case, yes, but Snakemake has support for sending things to a cluster. So it knows how to use, like, you can pass the commands for running S-batch, and then it's going to submit 100 jobs at the same time. So, and that's what Taylor does with her pipelines. So, but yeah, that's kind of the. Cool, thank you. Stop the recording and go for questions. Not Snakemake, conda questions, like general questions that people might have.